If an object is undergoing constant acceleration, we know its motion can be described by these three equations. I've written them here in the form including, well, the shorthand form with deltas and the longhand form where I've written out each delta as a final value minus an initial value. The problem-solving strategy in 1D kinematics, when we use these equations, basically follows the guess procedure. Givens, unknowns, equations, solve, and substitute. Let's walk through it. First thing you always want to do when solving one of these problems is draw a picture of the situation and identify the important events that are occurring. You don't have to be an artist, but a simple sketch, usually a number line with a few dots indicating the events, is sufficient. Next, you pick two of the events in your scenario. And for each pair of events, there's 10 possible variables to solve for. 10 variables that appear throughout these three equations. And here they are. Next, you want to identify for your two events which of these 10 variables are given to you, which are known from the information given in the problem, and which are the unknowns, which you might possibly solve for. Once you know that, you're going to identify which of our three equations up here, the constant acceleration equations, which of them can actually be solved, which ones you have enough information to solve. And sometimes none of them are solvable, which means you probably picked the wrong two events to start with. You might have a multi-step problem and you'll have to pick another two events and start there. Next step. Once you identified which equations are solvable, pick one of your solvable equations and write it out. In terms of the variables only, no numbers yet. We're not going to put in any numerical values until the very end. So write down the equation you're about to use. That's the best way to communicate to someone reading your work what you are doing, what your plan of action is, that you understand which physical principle you're using, which equation applies here. Write out the full equation. Then you're going to solve that equation algebraically for the one unknown. Again, no numbers yet, no numerical values, strictly in terms of the variables. Rearrange the variables to solve for your unknown. Only then do you substitute in your numerical values for each of those givens that you have and compute the result for your unknown. Lastly, sometimes at that point you still won't have your final answer. It might be a multi-step problem where you now need to move on to consider another two events in the situation. So update your list of givens and unknowns. You've just solved for something, so some of your unknowns have become knowns now. Some of your unknowns have now become givens. Now, so then pick another pair of events and repeat those previous steps.